Okay, in this last tutorial in the FlatBuffer series, I hope, I'm going to go over the documentation and I'm going to give you a real-world example of FlatBuffers that I'm using right now. At least in a preliminary fashion. I'm not going to show you one of the finished ones, and this one's much easier to follow. So when we go through the documentation here, boy, this is bright. I'm so used to dark mode, I'm having to use Edge, so you don't want to use your own browser in a recording. Uh, sorry. It gives you some examples in all sorts of different languages. We're going to be using C# here, but I'm sure if you're using something like JavaScript for your Unity, though I'm not sure I know why you would, we're going to go over the C# here. So much like when we created our schema, we had a namespace. Here's an enum. I don't think I've ever used one of those for this before, but I'm sure you can. They have a union of equipment, which is an addition of tables. We have that old vector3, though I tend to make mine tables, not structs. I think structs are smaller, but I think they're less mutable. And I quite like muting things. I like changing values of these vector3s over time. We have a table, which is a monster, which contains a lot of information. A couple of shorts, which are just small ints. A name as a string. Friendly or not as a bool with a default value. Default values we didn't go over. That's important depending on your use case. A vector of scalars of unsigned bytes. U-bytes. Fascinating. We've got a color, which is up here as our enum of color. Don't get that confused with regular colors. And we have got another array of vector3s as well as some equipment here. Table of weapons, I would probably put this above here just in case for readability, because you build these top to bottom, smallest to largest, but that is okay. So this is just the tutorial for the schemas. Yep, there we go. So we keep going through. This is creating and writing orc flat buffers, so orc is going to be their monster. Just like we did, they use vars throughout this whole thing. I don't like using vars. So we made a flat buffer builder of size 1. They start on 1024. I have no idea why they would, but they made the docs, so I'm assuming they know better than me. 1 works fine for me, though. They create, same way we created vector3s out of, or vec3s, out of positions, out of floats. In the object's position, they're creating strings. They create a weapon out of said strings. They add some bytes to some arrays. They start an inventory vector. There's a lot going on here. There we go. Create their vector3s using whatever kind of random data they seem to be using here. And then, same as we did, when they finish an object, when they're using their root table, they go from monster, start monster, builder, they add the objects, the other smaller vectors and other tables, and then they end monster and use orc. And then we should have a finish somewhere around here. Builder, finish, orc, value. Then they do this, which is fascinating actually, that they have this here. I don't remember seeing this before, but buff builder.databuffer, this did not work for me. This did not work at all. This was all I was given originally, but that's okay. Now that this is here, use this. And then they don't tell you how to write it, which was why I got stuck. So if you're also stuck and your operations aren't working, go back and see if in saving at the end of that video, you can figure out what went wrong with the writing. Because mine went right, because obviously this is a tutorial and everything I do works all the time, no matter what. I definitely didn't spend 3 weeks making this work. When they load pretty much exactly how we did. They make a new byte buffer. Byte buffer. Byte buffer is stopping becoming a word for me, because I've said it so many times today. We have monster, get root as monster, so that we have an accessor. They keep using vars. It makes it really hard to track the information that you're storing if you use vars for everything. I don't recommend it. And then we can allocate the same way that we allocated X, Y, and Z to X, Y, and Z from our byte buffer. We can do that here as well. This is a good tutorial. If you want to convert over to JSON, you can. This makes it a little bit more human readable. There's other ways that you can do this. I'm not going to teach how to do this because I don't use JSONs, and that would be a disservice if I'm doing something that I don't know quite enough about. My example this is my editor object, which is my schema. I'm going to preface this whole thing with don't copy down my schema because it's not going to work for you because I'm not showing you the interface that uses these objects. So this is a good way to maybe do the transform, but this won't help you change the object's color or do anything else there. And this is not bug-free yet. There are still some bugs to be squashed in this information. So I have a table of vector 3s, same as we did before. I have a full table of position, rotation, and scale rather than just position this time that I'm calling GameObjectTransform. I have a table of properties, which is essentially I'm using an interface that I'm grabbing the interface's name, which is iSaveable. I'm grabbing that component's name from the object, from essentially the inspector. And then I'm interfacing with it to grab an array of floats that will be added to that object. For example, one of them has an enum for what texture the cubes should have on them. That is stored in here as an enum and is saved and loaded using that interface. Each property needs its own interface, but having it be so savable, I'm okay with writing something for each object that says, this is what you're saving, this is what you're loading. It doesn't get that complicated. Even with some of my larger objects that have 6 or 7 different properties, like the fan, so it needs strength, it needs length, it needs how fast it spins, it needs all sorts of things. Can it be turned off? Can it be turned on? Does it rotate? Does it do any of these things? Those are all stored pretty effectively. Then I have GameObjectData, which is the transform. The name of the object itself, this is what to spawn. This is not the same as the components to add to the object. And then our table of properties, which are the components to add to the object. So I start completely from scratch. I instantiate an object of this name that I get from addressables. I put it at this transform, and then I add these components. Otherwise, it's a totally blank slate. So I'm saving a lot of data. And then we have a list of those objects, which is the root type. Let's take a look. So I have a few more, because I'm using addressables, I have a few more libraries than you would at the moment. I also have a more complex file path. So I have a path, I have a name, I made them consts instead. That's a smart thing to do. You can name your file whatever you want. So this is mutable, this is not const. And then I have the addressables path. So this is for loading objects. You won't need this unless you're using addressables. I also have a slow mode because this loads so quickly, it's almost not fun to look at. So I figured users could enable or disable slow mode so that they can watch it load up. You'll see that when we get to that. So I create a directory of levels because this is a level editor. I should preface that with this is a level editor that I've been working on for the upcoming game called Telewall. Go wishlist it on Steam if you want to. There's a demo coming out soon. Go take a look. And then we start coroutines because I do this asynchronously, either on start or on clicking the button that I have in this interface, which is save and load, just so I can test this a little bit better. Again, not totally bug-free. Don't copy this down. It won't do you any good. For my error checking, we check to see if the file path is there or if there's an autosave. I autosave if the user does not press the save button and instead just quits. Helps to have an autosave. And then we find game objects. I just called them object right now. and put them on the list. This is pretty much everything in the level, and it destroys it. That's definitely a better way to do this. So this is if the user had just saved. This makes sure that you don't half save, essentially. Your mileage will definitely vary because you won't need to do this, because your users won't be doing this in the editor. So I'm making the game also from the level editor, so I need this kind of information. Again, a loose example. Same old data from our loader. We check to see if the data list is 0, in which case the file is empty. Let's just check. Then in an IEnumerator, use yield break rather than return. For every object in the list, we're going to get the value. We're going to instantiate. This is what this async operation is. We're going to instantiate the object, which is going to be called temp right here. So we load and instantiate that object. Make sure it works. If it doesn't, we break off. And then we set the position, rotation, and scale of that object using data in our data list, value t, value position, value x. If you have a lot of tables in your schema, you're going to have a lot of these going down. You're going to have to get a lot of different properties here. So this is, we have data, which is our game object list. We look at our data list of game object data. We get its value. We get transform, goes up here. We get its value, which is going to be position. We go up to position, which is vector 3, and we get x. And we do the same for y, z, rotation, and scale. For our iSavable components, we're going to add their properties into their components using their interface. This will not do you any good. This will be completely different from anything that you're doing. And if we're in slow mode, we just wait. Essentially, this is a sleep, which helps us to be able to see the level in a more interesting way as it gets built. You'll see in a minute. When we save data, I make sure that we have data to save. This is good error checking to do. We have that same saver. We have a game object array, which is a large number of save objects. You wouldn't normally put this here, but I'm doing some things within that are almost, because let me put this simply. Because of the way properties is structured, that I have to do all of this little mess to work with my interface. I can probably improve this. I need to instantiate this game object array before anything else, just in case, because I need to set this value. Then we use this array as a data list vector. However, this doesn't count as creating something larger before something smaller, because this hasn't been used yet, essentially. Let's put it that way. That's the simplest way for me to put it. We grab the position, rotation, and scale from local position, local rotation, and local scale. We create T from position, rotation, scale. So we have this, we created this, we're in T. However, this object isn't finished, so I can continue adding properties that are smaller to it. We're always going from smaller to bigger, but you can start one, but you can't finish it and then add a smaller property later. Check the documentation. It harps on that just about as much as I am right now. This is for adding properties. Essentially consider this that we're grabbing property values and property names, which are components, using my interface that are doing all sorts of different things. Then, rather than using start, add, and end, I actually managed to make this offset for game object data, which isn't our root type, by using create rather than using add. However, our root table, game object list, I can't make it work using create, so I'm using start, add, end, even though create looks like it would make sense. So we assemble this list of the three properties in each object: transform, prefab name, and all of the properties table. We throw them into an array, really a list and then into an array, which is our full data list. We start a game object list, which again is our root type. We add the list of game object data, which is the same here. It's an array of game object data, excuse me. Then we end, we put it into data, and we finish with data value. As if this wasn't complicated enough already. This is why I kept things simple. We have a buffer of saved sized byte array. I have this note in for myself that no matter what anybody tells you, saver, data buffer, length doesn't work. Just as well as using memory stream, which I think is in that XIM tutorial with the purple logo, the magenta logo, that also doesn't work for me. I've never gotten it to work. We assemble our path depending on if we're auto-saving or not. We debug, and then we write. And we do that on application quit, or when the player presses that button. Is that complicated enough yet? No? Well, let's see how it works. As you get used to your own FlatBuffers implementation, this gets so much easier, but just talking about it is exhausting because I know how it works, kind of implicitly. But if I had to explain this, this would be very difficult. So this assembles our level. This is mostly just a test. We can move around our level editor a little bit here. These errors are not related to FlatBuffers. These are errors I'm squashing whenever I press the W button because it's been assigned to more than one key. So let's say I want to, here, I'll load it up again. This is how quickly this loads, virtually instantly. That'd be a great loading screen. If we throw it into slow mode, it loads a little bit quicker. Let's see how we can do this. So if you wanted to show kind of a little GIF of the level loading, I thought that would be really nice. So I'm doing this asynchronously. But ultimately, I think I like it. Just the way this goes. Make for a nice GIF. Anyway, we can lower one of these cubes, press save, throw them out. Oh, let me undo slow mode here. And it's back in the position it was. If we raise it back up, we save, throw it away, load, puts it right back where it needs to be. Save the, or change the scale on this object here. Make it, can make it a little wider here. Nice wide platform. GitHub won't leave me alone. We'll save. Shrink it back. Nope. Shrink it down like this. Load right back where it was. FlatBuffers implementation 101 here. We can add some more. I can delete a bunch of random objects. We load, everything's right back where it needs to be, and it's almost instant. This is why I made this tutorial on FlatBuffers. I hope this helps you. I suppose if you want to support what I'm trying to do here, educating people, teaching on Unity, both online and my job with the university, I suppose you can wishlist Teleball on Steam if you'd like. It's the only thing called Teleball. I'll be finished with it at some point. Maybe one day you'll be using this level editor to make some levels or something. That'd be fun. All right, thank you for watching. Hope this helps.